Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are continuing our discussion on complex numbers. Hence, the part 2. Let's get to it, shall we? Find exact values for a and b if root 2 plus I is a root of x squared plus ax plus b is equal to 0. So here's an example where knowing this really does come in handy. We have the quadratic. It is of this form. There is no a here. So I do know that if root 2 plus I is a root, again, root 2 minus I is also a root. And the sum of these two is 2 root 2. And then the product of these two, root 2 plus I times root 2 minus I. I know we can do it in our head, but I always like to write it out, is equal to root 2 squared minus I squared, which becomes 2 plus 1, which is 3. Now notice how they have it's of the form c squared plus d squared. I always go ahead and multiply it out, but it's always going to end up as c squared plus the d squared. So c plus di, the d is equal to 1. So 1 squared is 1, and root 2 squared is 2. So therefore, you get the 2 plus 1 equal to the 3. So what we end up with using this form is x squared minus 2 root 2x plus 3. And we know it's equal to this guy right here, which is x squared plus ax plus b. And therefore, we get a equal to negative 2 root 2 by equating coefficients, and b is equal to 3. And again, we could have, if we didn't remember this, we could have taken x minus root 2 minus I times x minus root 2 plus I. And let me just cut this off right here because it's a separate thing. So all this is taking x minus this root and then x minus this root. We could expand it and we would still end up with x squared minus 2 root 2x plus 3. And then we could still equate it and get the same result. Again, it is up to you. Okay, so last example. Show that for all, well, let me go back up here. So in class, we'll talk about this, but we'll do a little bit of investigation, and we'll find out all of these relationships between a complex number z and its conjugate. So, for example, z star star is equal to z, and all these, I'm not going to go through all of them, but they're all there. So we're going to show, actually this one, show that for all complex numbers z1 and z2 that this is true. So in order to do this, let's just go ahead and let z1 equal a plus bi, and we'll let z2 equal c plus di. Okay, so we're going to go from left to right. So, well, I guess before I do that, if this is true, z sub 1 star, the conjugate, is going to be a minus bi, and z sub 2 star is going to be c minus di. Sorry about that. So let's start here. z1 plus z2 is going to be equal to a plus bi plus c plus di. And writing that in complex form, that would be a plus c, the real parts, plus the imaginary part, b plus d times I, if we factor out an I here. So now z1 plus Z2 star, which is the conjugate of the sum, would simply be the real part minus the imaginary part. And if we distribute the negative, we would get A plus C and the I minus BI minus DI. And if we arrange it just a little bit, we're going to get A minus BI here and here plus C minus DI, which is the same as Z sub 1 star plus Z sub 2 star, which we had written right up here. Okay, so an easy little algebraic proof just with some algebraic manipulation. So let's do the same thing here for part B. This was part A. So let's do part B. So let's shake this out and see what happens. So we'll use the same values that we used here for Z1 and Z2. So the first thing we're going to need to do is find Z1, Z2, which is equal to A plus BI times C plus DI, which is going to be equal to AC plus ADI plus BCI plus BD I squared. And let's clean it up. That's going to be AC. And by cleaning it up, I mean we're going to gather our real and our imaginary parts. And we're going to skip a couple steps here. So remember, I squared is -1. So the real part of the complex number would be A times C minus BD. Because again, I squared is -1. Plus, factor out the I, and we have AD plus BC times I. So that's Z1, Z2. So that means that Z1, Z2 star, which is the conjugate, the complex conjugate of the product of Z1 and Z2, would simply be the real part, AC minus BD, minus the complex part, AD plus BC times I. Okay? Extend the page a little bit. So now I'm going to do Z1 star times Z2 star. So Z1 star times Z2 star. Okay, now what is the conjugate of Z1? That's right here. This would be A minus BI. Conjugate of Z2 would be times C minus DI. And maybe you already can see what's going to happen here. It's going to work out quite lovely. So this is going to be AC minus ADI minus CBI. Is this looking familiar? Plus BD I squared. We clean it up again, and we get AC. This is BD I squared. So that's going to be minus BD. Okay. And then we gather our i's and we factor out a negative I because it's a negative ADI and a negative CBI. So I'm going to factor out a negative I and end up with AD plus BC. I don't know why I put CB there. I, which matches what Z1, Z2 star is. So therefore, we can say that Z1, Z2 star is equal to Z1 star times Z2 star. There's a Z1. All right, as required. So that is it. Hope you enjoyed it. And with that, I am so excited to say that I am out.